to about the electrical conductivity as per the free electron theory. Okay, before starting, I'm gonna start with some theory. In previous lecture, I have discussed about the electronic theory, classical electronic theories about this Elson. So, okay, let us start the topic. So it start with the base. It started with like the basic theories, like the on the of free electron, basic of free electron theory. Electron move freely in solid. Like we already read in the assumption of the electron theory, that on the basic of free electron theory, electron move freely in the solid. When we apply electricity on the electron, when we apply electricity on the electron move in the particular direction, like E with the applied electric field and M with the mass of the electron, the charge of the electron, and the charge of the electron be their small e with the charge of the electron, M with the mass of electron, and E with the applied electric field. So when we apply electric field, we already know that the electron start to move in particular direction. So the okay, after that, so the force experienced by the electron in external field, in this case external field is the electrical field that we apply in the metal. Okay, this is the haliter. Okay, and that after that we have to know that the force equal to the energy of electron and the applied electrical field, applied energy force and the applied energy of electron and the applied electrical field. Okay, we also know that we already know that the F equal to have a mass into acceleration, force equal to mass into the acceleration. So we consider it as the equation 2 and this is the equation 1. So from equation 1 and equation 2, E equal to m, capital E and small e equal to m. So we got there A equal to E by m. This is the equation of the acceleration. So let us move below. After that, like tau, this symbol is called tau, or tau with the relaxation time. Tau with the relaxation time, and Vt with the average velocity of the electron, known as drift velocity. Okay, here we got the velocity, drift velocity definition. The definition of drift velocity goes like this: the average velocity of the electron is known as the drift velocity. Drift velocity and tau with the relaxation time. Okay, after that, we have to know that the drift velocity is equal to acceleration into time. This is another relation, that the drift velocity is equal to acceleration into tau, a tau. Then after that, we already got the value of the acceleration from equation 3. Let's take the equation 3. This is the value of acceleration. So we put the value of acceleration in there. So we got E, capital E tau upon m as equation 4, where A equal to E by m. Sorry. After that, let me change the highlighter. After that, let I be the current carried by the conductor on electrical field. I be the current. We already know that I is the current. So I be the current carried by the conductor on electrical field E. Electrical field is known as E, capital E. So let in a small time dt. The time is here, that small time is denoted by t, and the small portion of the time is denoted by dt. The distance covered by the electron be p d dt, means this is known as the drift velocity. Dt is in small term, like the velocity and the time. Okay, the distance covered by the electron is now p d dt. So after that, number of electron. After that, the number of electron in is crossing any, the number of electron that is crossing. Okay, sorry, I have written some mistakes. Let me correct it. Okay. So the number of electron that is crossing any cross-sectional area A, in time dt is given by A v dt. It's simple. After that, let n be the electron per unit volume of the conductor. Let n be the electron per unit volume. The electron in the per unit volume of the conductor be n. We consider it as n. The total charge flowing through the cross-section area in time dt. Time dt is given by time t is the small portion of time. So which is given by the charge, the total charge. The total charge is now we charge the q. So in a small time dt, the charge is now considered as dq. Yes, and after that the total charge become dq, and dq is represented by n a v dt, and here E is a constant. So since we already know that charge I equal to, okay, let me correct there also. Let I equal to dq by dt. Yes, this is the old relation that we have already studied in our previous classes, lower classes. Okay, now that I equal to dq by dt, we are going to put the value of dq here, like this value is going there, and dt same as below, and now we have dq dt upon top, and below we can call them, they are cancelled. Now I equal to en a v dt, en is only vd, dt is cancelled here. Okay, after that, let me change the highlighter. Let me go down below after this. Okay, I'm sorry. I'm going to tell you that here the density. Okay, here the current density will be J. The density of the current is denoted by J. So J equal to I by A. Density equal to amount upon area. So there the density of current equal to current amount upon area. So density, which is denoted by J. J means density, current density. Okay. Now we already have I value of I from this. I equal to E1 A VD upon V1 A VD or V1 A VD. So V1 A D by A. So A and A are cancelled. So we get the new equation y is equal to NEVD. Again by using equation second. Okay, let me show you the equation second here. This is the equation second. The value of A here is A equal to EE by M. Okay, we are using it here. Now we are using the value of A in VI. A in VI, that EE by M. No, this is the value of VD. VD. Okay, sorry, I got a mistake there, that we are using the value of VD. So the value of VD was in their equation 4. EE tau by M. EE tau by M. So I have read this value as the second, so sorry for the mistake. Okay, now we get here J equal to n. After putting the value of VD, we now get the J equal to N E square E tau upon M. Okay, another we have to know that J equal to sigma E. This is the value of J, also known as J equal to sigma E. So by comparing these two equations, okay, after that comparing the equation Vi and V triple I, we get this sigma equal to N E square tau upon N. Then these two equations are here, we are seeing that it's J and the J. So we are comparing these two, cos J and J is equal. So after comparing, this E and E are cancelled here, and after the remaining part is this, and we consider it as equation 9. So another portion of this topic was this is we are going to consider the resistance here. So let me change the highlighter. Okay, let me scroll down a little bit. Okay, now if R is the resistance of the conductor, and we have to know that R equal to this R equal to now, and here this is resistivity of a material, this is length, this is area. Okay, resistivity of material, this is resistivity of material, this is length of the conductor. Okay, now again I have to know that I equal to JA. J means the density, and A means the area. Now I already told you that in upper section that J means the density, which is equal to the sigma E. J is equal to the sigma E. So the equation become I equal to sigma EA. Now we also know that sigma equal to 1 upon resistivity. Sigma equal to 1 upon resistivity. So the equation now becomes this. We are going to put the value of sigma. We are going to put the value of sigma in there. So this becomes this. After that, we are going to put the value of resistivity, like the RA upon real. Resistivity means the RA upon real. So we are going to put this. It is 1 upon resistivity. So these two values are inversed here. So it becomes L upon RA into EA, and A are cancelled. So I equal to EL upon real, which is going to be our the 9th equation. Okay, let me scroll down a little bit. Here we have to know that the applied potential across the conductor is constant. We have to know that the applied potential, the potential that we applied in the conductors must be constant. So it is constant. So if it is constant, now we have the value of E, like the E equal to V upon L. E equal to V upon L. This is the value. Sorry, this is the value. So from equation 9, this is the equation 9. We have gotten the value of E as V by L. So from equation 9, I equal to VL upon LR. We are going to put the value of E in there. So we got I equal to V by R, V equal to IR, which is known as the Ohm's law. We already know Ohm's law. We have studied about the Ohm's law in small classes like Ohm's law. So this is small Ohm's law. Now we have proved this also. Sigma equal to N squared tau upon M in upper section. So from here mu equal to small e tau upon n, which is mobility. Mobility means drift velocity per unit electric field. Mobility means drift velocity per unit electric field. Okay, that's easy. Small e tau upon m is mobility. Let me change the highlighter. Okay. Sorry. let lambda be the mean free path. Now we consider lambda as the mean free path and beta be the root mean square of velocity. Then we again get the another formula for the we get another formula for of the tau. Then tau equal to lambda upon b dash, this is another relation. So from the assumption of classical theory, I have write there half. Let me write from the assumption of classical theory. No, okay. From the assumption of classical theory, we have to know that the 3 by 2 kbt equal to 1 by 2 mv square. So we got this. After this, we were going to separate this v from everything here. Okay, after that we're gonna separate this v and we are going to put this in divided by this. Okay, b dash square equal to 3 by 2 kbt. After this square is going to be here square root. So we got the relation of b dash equal to root over 3 kbt upon m. Now we have write the relation here, tau equal to lambda upon b dash. So tau equal to lambda upon b dash is here, this b dash equal to root over 3. We're gonna put it here. So we get that lambda root over m upon 3 by 2 kbt. This was reversed, so it is going to upward, so we got this here. Okay, now we know that sigma equal to n e square tau upon m. So n e square, we're gonna put the value of tau that we get here. So we're gonna put the tau value here. This is here. So upon m, now this sigma equal to n e square root over m upon 3 kbt upon m. Now we got this everything here like this. We know that n e square, this is lambda, this is 3 m kbt root. After the equation become here like this m equal to we have to know that m equal to m root over m. So the and so this m and this m and this m are cancelled here, like we have to write the root over m here. Okay, that's not sorry, to remove this, like m equal to n root m into n. So this m and m are cancelled here. So this is there, and now there is only remaining this is not cancelled. So now the equation for n is quite n is square lambda upon root over 3 m kbt. So 3 m kbt here. Mean free path, I'm going to tell you about which is mean free path. So I'm going to tell you about the mean free path. What is mean free path? Mean free path is the average distance covered by an object in a collision. The mean free path is an average distance covered by a collision in average by an object in collision. Okay, now we have sigma equal to 1 by rho equal to 1 by rho. Now we get the value of sigma here like this here. So it is root 3 upon this is equals here, so root 3 m kbt upon n e square lambda. So we get the relation about sigma and the temperature. So resistivity rho, the last statement of this is resistivity. Okay, now the last statement was resistivity rho varies with the temperature. Now it is we get the relation like the resistivity rho varies with the temperature, where it is totally found to be wrong. So it is said that the classical theory has some limitation. Resistivity doesn't vary with temperature, whereas it varies with resistivity doesn't vary with the under root T. It varies with the temperature. The contrary, it varies with temperature. Like it is found that resistivity varies with root over T, but it is not true. It is not true. The true was that the resistivity varies with linear temperature. Linear temperature was like this sigma belongs rho belongs to direct T. This statement is true, but this is not true. So it proved that classical theory must have some drawbacks. Okay guys, let me know that how was the video, and now I'm going to close this session because it's already the midnight, about the 3 no it's already morning at 3 am, so I have to go to sleep. So thank you for watching. Please note that this everything I'm going to write here was totally exam based, so please copy down. Okay, I'm going to give you all the screenshots in the description link. So thank you for watching. Bye.